Hey there, Math 126 fans. Going to continue our journey to try to reflect on exam 1 and hopefully do better on future exams. This is page 3 of the summer 25 exam 1. Let's go through the parts. So the first part had you name a shape. That's something I think I've asked on almost every exam. So if you're looking in the exam archive, you see that a few times. If you forgot, you don't even need a table to do this. You ask yourself, what if x is a constant? So step 1 is to say, if x is a constant, then I were to graph that. What is it? It's a parabola. Let me move this out of the way here. And 80% of the class got this right, so I'm kind of recapping something that a lot of people know. If you replace y with a constant, then you'd have a constant on this side. And that has a minus between two squares. That's a hyperbola. And then lastly, if you make z a constant, that's a parabola. And so remember, the easy way to remember these names is if it looks like a parabola from two sides, when the traces for two different variables is a parabola, then you call it a paraboloid. The adjective you put in front of it is the other direction. This is a hyperbolic paraboloid. 80% of the class got it right, so I don't think it's worth talking about anymore. But if you're one of the 20%, this is one of those things where you're like, how did I miss that in my studying? Okay. That's on lots and lots of homework and old exams. Okay, the next question was said, you've got this loop thing. And what I was trying to do here, maybe this backfired, but I thought, hey, let's do a question where you just get to analyze something that's sort of interesting. A loop. Oh, so here's a picture first, I should have said. This is a picture of that hyperbolic paraboloid. Okay. So let me say a couple things about that loop. So that loop looks like this. You say, well, what do I do if I can't visualize it? So in this problem, I ask questions from the homework, similar to the homework, that guide you through how to analyze such a thing. First thing we try to do is we try to visualize surfaces it's on. What surfaces is it on? Well, it's on the cylinder, and I didn't prepare this. X to the second plus y to the second equals 1. Every point is on that cylinder. See that? Ooh, that helps me visualize it. And the point is, you don't need to make a 3D picture to know that. Every point on there. And that was a big topic from 13.1. What else is it on? It's also on, and I'll go through the problem in a second, but it's also on this plane. How did I get that plane? That's z equals 3x. So you can see how each one, really those two alone, give me a really good picture of it. But let's just complete the picture. Y to the second plus z to the second over 9 equals 1. That's this elliptical cylinder. It's on all of those. You can see how that really gives us a picture of what's going on. That helps us confirm, okay, it's this loop that's kind of tilted like this. On a cylinder from above, it looks like it's on an ellipse from the side. And from this side, it looks like it's on a plane. Okay, so back to the question itself, how do you do that? And so this quarter, I added a couple questions to the homework because it's always something that students ask about and are confused about. So I thought, all right, I'll add a couple questions. And I did. I added several. One that I added was this one. So my one comment, if this question really got you, because only 25% of the class got that completely right. A lot of people had part of it right. So I suspect it was just maybe if you were just studying old exams and not thinking about the homework, this might have been the issue. But my question to anybody that got this wrong is, and again, I never mean this to be negative. I feel like I have to say these things to like get us all on the same page. If an exam didn't go well or you weren't able to study, that's a separate thing. But just listen for a second. So when you did this homework, my question is, how did you do it? And this homework was about this exact topic, which was eliminate the parameter. So we solve for t x over 9. And what I'm trying to do here is just make the homework mean more to everybody. Because I think I'm making a good point through all the stuff we're doing, that everything in this test was in the homework. So if you did the homework and thought you understood, and then got to the test and couldn't do a similar question, then that brings into question like how we're approaching the homework. I hope that makes sense. And similar, you could plug this in here and get e to the x. Every once in a while, somebody misses something, whatever. And then lastly, can we combine these two in some way? And I think that was harder than the test question, because in order to think about how to combine those two, you might have had to realize that z was e to the t to the 9th, and so z was y to the 9th. And if your response to my question is, well, I didn't know how to do that when I did the homework, I just looked up the answer or something, then that's the issue. That's what we got to think about. Or you say, I did it some other way. Those are the things to ask me when you're studying. So the point of this question was, we knew x is cosine, we knew y is sine, so hopefully immediately knew that cosine squared plus sine squared is 1. We actually did that on a whole bunch of homework questions in 13.1, like 8 in a row. So this one hopefully we got. Then you start to go, well, what other things can I combine? Well, I can combine x and z, or the order didn't matter. Any of these three would have been fine. But because this is x and because this is z, because those are both cosine, you can just say, oh, that means z is equal to 3x. And if I was going to visualize that, that's what I would have thought. I would have thought, this thing is on a cylinder and on a plane. Okay, I can visualize the closed loop. That was what I was trying to do in this question, was do something kind of practical of, once I know those two things, I feel like I know what this looks like. Okay, the last one was, okay, what two things have we not combined? We haven't combined y and z. And remember, the strategy there is if you have a sine and cosine, you get the cosine by itself. So I took this and I divided both sides by 3, and then this square plus that square has to be 1. And this was an elliptical cylinder. Okay, so that was it. So a lot of people on that question did miss 1, 2, or 3 points. That kind of lowered the grade slightly from what I expected. Not dramatically, but like I said, I was looking at the homework, that particular homework question, when I thought about that. All right, but I hope that at least clears it up, and I hope you can see the value of being able to do that. Next question, I asked you for an arc length. I said you didn't have to evaluate it, and you just a straight computation. So what if you wanted to know the length of this closed loop? You take the derivative of x, you take the derivative of y, you take the derivative of z, you square, and it's this thing. Oh, I meant to calculate this integral. Maybe I will in Desmos here in a second. But to me, that's kind of interesting because we're actually using this to do something. Now, how do I know it's 0 to 2 pi? And that's because of the equations. This is a circular parameterization, which finishes a loop around this from 0 to 2 pi. So that's how we know that, and that's how the previous part kind of helps us understand that. But let's look. So I'm going to say a few things with the picture. Again, you didn't need the picture. I just think this is kind of interesting to see. So if I show you what the actual object is doing, it's doing this. It's going around like this. Fun. It does one loop from 0 to 2 pi. So if I change to 0 to 2 pi, there it goes. And the length, I'm going to type this into Desmos. So the integral from 0 to 2 pi. And this is how we would use things like this. We would put it in an integrator in practice, but you still would have to know how to set it up. So if you wanted to length, so it's 13.47. So it's about 14, feet around that thing, because I was able to compute that integral. Okay. All right. Last piece, last question. And the TA said he was kind of surprised at how many people missed this. Now, a lot of people got the arc length right, but we were surprised this wasn't higher. This particular question was identical to question 8, very similar to question 8, almost the same, and question 9 of your 13.2 homework. If you look on my old exams, I've probably asked this every other exam for the last 10 years, so it's pretty common on there. The TA said the most commonly missed problem, because they graded this one, I graded 2 of the other pages, was students didn't know how to find the T and the U. Now that is something I remember us stopping and talking about a couple times in class and at least once during the review. And it's just a common mistake. So if someone tells you x is 1 and y is 0 and z is 3, and you want to know what t is, you have to go back to the original equations and say, well, x is cosine. So I need 1 to be cosine, I need 0 to be sine, I need 3 to be 3 cosine. Now the truth is that has lots of solutions, but they all are the same point on the curve. So really you can use t equals r. If you used any other values, you're still going to get the same value. We'll see that in a second. And then you need to find out what is the u when the first component is 1 and the second component is 0 and the third component is 3. And notice 1 works for all those. Okay, the second piece is the angle of intersection. This was a big topic we talked about in 13.2. So this is a fairly standard question. It does have a few parts, but I know we did this in the review and we did it in class and we did it in the homework. So you want the angle between their directions at these values. So you get the 10 star fact, this fact about the dot products. Again, this is A dot B, magnitude of A, magnitude of B, cosine of theta. And you plug it all in, you solve for theta. Okay. So if you missed that, you missed kind of a big topic that we talked about a few times. Most of you, 53% got it completely right. Quite a few got it mostly right. So overall, we're seeing that, 60 to 70% of the class is getting these things, which is great. I just think it should be all of us. I'm trying to get us all there. Okay, so let's do one more thing before I finish this video. I wanted to show you the angle of intersection just because I think it's fun. So here's this thing again. I'm going to make this just a little bit bigger. Okay, so there's that curve. The other curve is this one, this green one. And they meet right there near the top of this. Let me make this a little bigger. That's plenty bigger. Let's go here. I hope some of this is helpful. I don't mean to be joking or whatever. That's not my intention, so apologies for that laugh. I was laughing at myself for messing around with that graph. But I hope some of this is helping. You don't need to be able to visualize. I'm doing it just to show you that the stuff you're computing actually matters, and sometimes that helps. You're actually doing something in 3D. That particular curve might not matter to you, but maybe in a future course, this is why you're at this. We're trying to find the angle of intersection at that point. What that means is we're trying to find the angle between them where they meet. So there is, for one of them, the vector when t is 0. For the other one, did I graph the other vector? No, I didn't. I don't have it ready. But you can see there, if you're going to look at it, we want the angle between them, the angle between their tangent vectors at that point. It's about 58 degrees. So that makes sense. If you kind of look at it from the side, maybe that looks like 58 degrees. Let's zoom in. So is any one of those questions that interesting? Maybe not. But I hope that you're seeing that we are computing something. This isn't just some made up messing around by a mathematician. Okay, so there you go. Ultimately, I think, like I said, the question that got most people was this one, but one question, those were 3 points, and a lot of people got 1 or 2 points. It's not the end of the world. But that one, if you missed that one, a lot of people did. The other things are things we really should have gotten, and you can see a lot of your classmates got them, so I hope you're getting a little bit out of these videos.